Whoa! That's pretty cool, huh? Now, how did that happen? Hi guys, it's Glenn with Expulsion Science, and I'm back on my tricks, magic tricks. We're gonna pick up some ice using nothing but this little piece of string. Before I show you how, let's gather our materials. We need a bowl of water with ice in it. We need some salt, as well as our little string. There is nothing special about my string, as well as there's nothing special about my ice. But what we're gonna do is we are going to place a string over top of this piece of ice over here, and we're gonna see if we can pick it up. Let's wait for just a second and we'll try it. Will it work? Uh-oh. Wonder why that happened. Let's try it again, but let's leave this on top of there. We're gonna take some salt and start pouring it on the top of it. We make sure it's down on there. Really good. Ready? Here we go. Whoa! That's pretty cool, huh? Now, how did that happen? By adding salt to the ice, I'm lowering the freezing point of the water about 4 degrees Fahrenheit. So some of the ice melts and then it quickly refreezes over the string. We use the same logic when we add salt to the roadways during an ice storm. The salt lowers the freezing point of water, causing the ice to melt and hopefully keeps the roadway from becoming slick. Stay tuned for our next experiment with Expulsion Science. So we know that the freezing point of water is 32 degrees Fahrenheit. That's the temperature at which liquid water changes its state of matter and freezes into a solid, ice. However, sometimes water can cool below freezing point and remain a liquid. When water is in a liquid state, the water molecules are active and bounce around. When the temperature cools, the molecules slow down and bind together through crystallization. This could be from an impurity in the water, such as a speck of dust or a crinkle in the container, or a shock wave sent through the liquid by a sharp movement. All right, let's see if we can supercool some liquids and insta-freeze them. As always, let's gather our materials. So we need a bowl filled with ice, as well as some water. We need a thermometer and some salt. So we're gonna start off our experiment by putting some salt on top of the ice. So we're gonna start right over here. We're gonna put a pretty generous amount on there. Remember, this is gonna lower the freezing point of water. Now that we put our salt on, I'm gonna set this aside for a second and let it supercool for a bit, and then I'm gonna have my assistants, Stu and Brooks, come in and show you how to insta-freeze them.
Okay, Stu, what do we got here?
So we've got these bottles that we've put in the bowl, and then we put that whole bowl in the ice in the freezer, and we got them real cold.
How cold did we get them?
We got them down to about 30 degrees Fahrenheit, so below freezing, pretty chilly.
Well, let's see what happens when we slam them. Whoa!
Look at that. The water turned instantly into ice. That was so cool, literally. It looks like they triggered a sharp shockwave through the bottle and initiated the crystallization of the water molecules and instantly froze the water. Okay, everyone, you not only have a cool trick to show your friends and family, but you know the actual process of the crystallization and how to control it. Catch us next time on Expulsion Science.